All right, so let's start with number 12. It says in the diagram below, find the measure of angle B and the value of x. You guys actually had one that was almost identical to this on the skills check yesterday. This was question number 2 on the skills check. So what I can see in the figure is that segment BC and segment AC are congruent. That makes this an isosceles triangle. And what we learned about isosceles triangles is that the angles that are opposite the two congruent sides have to be congruent to each other. I have no idea how big either one of these is, but I know they have to be the same size because they are opposite the congruent sides. So I'm going to give them a letter name. I can't choose X because X is already being used in these expressions. So I'm going to go ahead and call this Y. So I know that the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. We don't know how big angle A is. We called that Y. We also don't know how big angle B is. We called that one Y also. And we can get away with calling them the same thing because we know they are the same size. If we did not know they were the same size, we could not call them the same thing. And we can't call them X because X is already in use. All right, so I'm going to combine my like terms together. We're going to combine Y and Y. That would give me 2Y plus 60 equals 180. I'm going to minus 60 from both sides. I get 2y equals 120. And then we divide both sides by 2. We get that y is 60. So that means that angles A and B are 60 degrees. So angle B is 60 degrees. The other thing I notice is because those two angles are 60 degrees and this angle down here was already 60 degrees, this isn't actually an isosceles triangle. This is equilateral. I didn't know that until I found out the sizes of the other two angles, but now that I know that the other two angles are the same size as the third angle, I know that I'm looking at a triangle where all three sides are congruent. So BC, AC, and AB are all congruent. Since those are congruent, I can set side AB equal to side BC. Segment AB is congruent to segment BC. So the length of AB is equal to the length of BC. So 2x minus 1 is equal to 3x minus 7. Get our x's to the same side by subtracting 2x from both sides. I get that negative 1 equals x minus 7. And then I add 7 to both sides. Negative 1 plus 7 is 6. So x equals 6. The first thing I had to do was figure out the measurement of angle B. That was the key to unlocking the rest of this problem. If I hadn't known that all three angles were the same size, I could not have solved this problem. What else would you guys like to see from the review?
Number 13.
Number 13, absolutely. This is another one that is very similar to what you had on the skills check yesterday. So we want to determine whether we would use side, 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 angle, side, angle, side, angle, 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 side, hypotenuse, leg. Or if none of those will work, then we're going to write none. So let's look at this one picture at a time. So anytime I'm looking at a figure where my triangles are connected, they're touching, there are two things that I'm allowed to mark up, even if it's not already marked on the picture. What are the two things that we are allowed to mark? Vertical angles and shared sides. Do we have either one of those here in this triangle set? We have a shared side, so I'm going to go ahead and mark the shared side. I have to give it a different number of marks than the other pairs of sides that are already marked as congruent. And now if I look at just one of those triangles, I need you to put that away, please. What do we have marked up on the triangles? Side, side, side. All three sides of one triangle are marked as congruent to all three sides of the other triangle. All right. Coming over here to the other one on the top, is there anything that I am allowed to mark here? AC, I can mark as congruent to itself. I have to give it a different number of marks than sides A, B, and CD because it's not congruent to A, B, and CD. It is congruent to itself. Looking at just one of these two triangles, what do we have marked up here? Side, angle, side. We have two sides and the angle that is in between those sides. This is in between my two marked sides. All right, middle left. Is there anything that I am allowed to mark on this picture without being told? Vertical angles right here at K. Now looking at just one of the triangles. How many sides and how many angles do we have marked? Two angles, one side. Is the side in between the two angles? No. This side touches this angle, but this side does not touch this angle. It is opposite that angle, so it's not in between the two sides. So is this angle, side, angle, or angle, angle, side? Angle, angle, side. Or you could call that side angle, angle. What do we have marked up on the middle right one? Yeah, we have an angle marked here. We have a side marked here. We have another side marked here. Are we allowed to use angle, side, side? No, so this would have to be none. Bottom left, coming down to the last couple problems. What are we allowed to mark on this one? Yes, this is hypotenuse leg. We're allowed to mark our shared side. That shared side is opposite the right angle on both of these triangles. So that would be my hypotenuse. And the other two marked sides are legs because they are not opposite the right angle. So this is hypotenuse leg. You have to have right angles for hypotenuse leg, but just because you have a right angle does not mean it has to be hypotenuse leg. Right, and then we get to our last one. Yes, sir.
So what does make a hypotenuse leg?
The hypotenuse is marked as congruent along with a pair of legs. You have to have the side across from the right angle marked as congruent, and then you have to have one other pair of sides marked as congruent.
Okay.
All right. Last one now. We have our shared side that we can mark. And then, do these arrows mean congruent? What do they mean? They mean parallel. When we see parallel lines, we draw what shape? A Z. So I can draw a Z like this. If I draw that Z, then the angles that are congruent to each other are this angle here and this angle here. Make sure you're matching the color to itself. This is one of the things that I noticed on the skills check yesterday. We knew it was alternate interior angles, but we were marking the wrong angles. Notice when I drew in those angles, I had to match pink to pink. I could not do this because this side doesn't have any pink on it. But then I have another pair of parallel lines. I have this parallel line, I can connect it here, and then this parallel line. So that gives me another pair of alternate interior angles. And so now I'm going to look at just one of these two triangles. What do we have marked up here? Angle, side, angle. Here's an angle marked. Here's another angle marked. And then we have the side that is in between them. This side touches both of my angles that are marked as congruent. So angle, side, angle. Angle, angle, side. The side only touches one of my angles. Angle, side, angle. The marked side touches both of my marked angles. What else would you guys like to see? Which one? 14. Number 14. Using the information below, draw and label a diagram. Triangle TOM is congruent to triangle DAN, and TO equals 4x minus 20, DA equals 2x plus 2, and AN equals 7x minus 12. So it said the first thing we need to do is draw a diagram. So we're going to draw two triangles. So there's one. And there's the second one. And I need to label them. One of them is TOM. The other one is DAN. And we need to mark them up with all of their congruences. It says draw and label. That includes congruence markings. So I need to use this triangle congruence statement here to figure out which angles and which sides are congruent to each other. First letter here is T. That corresponds to the first letter over here, D. So I know that angles T and D are congruent. What would be another pair of corresponding congruent angles? O and A, middle letter, middle letter. So O and A. And what's my last pair of corresponding congruent angles? M and N. And then we can also use this to match up our corresponding congruent sides. When I look at this, I'm going to look at first two letters, TO. First two letters over here, DA. So segment TO, side TO, is congruent to side DA. What would be another pair of corresponding congruent sides? OM and AN, middle and last letter, middle and last letter. OM, AN. And finally, that means what other pair of sides would have to be congruent? We already did that one. That's what we just did. TM and ND or DN, yes.
So is it all because that the triangles are congruent, so pretty much
It's all coming from the triangle congruent statement from these 6 letters right here and the order that those are in. Notice OM is the middle and last letter here. AN is the middle and last letter here. That's how I know they're congruent. It's not because of the way the picture is drawn. It's because of what the triangle congruent statement says. All right. Then we also know that TO is 4x minus 20. So this is 4x minus 20. We know that dA is 2x plus 2. And we know that AN is 7x minus 12. We are supposed to solve for x, so I need to find a pair of corresponding sides that I can set equal. And I need both of them to have x. What's a pair of corresponding sides that I could set equal, that I could take my two expressions that both have x and set them equal to each other? Segment TO, 4x minus 20, and segment DA, 2x plus 2. We said that these were corresponding sides. Because of my triangle congruence statement, I know that they are congruent. So segment TO is congruent to segment DA. That means the length of segment TO is equal to the length of segment DA. So 4x minus 20 is equal to 2x plus 2. We're going to solve this for x now. We're going to get the x's to the same side first. So I'm going to minus 2x from both sides. That gives me 2x minus 20 equals 2. Then I'm going to add 20 to both sides. So I get 2x equals 22. And when I divide both sides by 2, I discover that x is what? X is 11. They asked me to find one other thing on here. What else am I supposed to find? The length of OM, which is right here. I don't have an expression there, though. How am I supposed to find that? We set it equal to AN. Notice those are both marked with two congruence marks. That means that they are the same size. So segment OM is congruent to segment AN. The length of segment OM is equal to the length of segment AN. So OM is 7x minus 12. Substituting in the x that we found of 11. So I have 7 times 11 minus 12. What is 7 times 11? 77 minus 12? 65. So OM is 65. Beautiful. What else would you guys like to see? Number 16? Absolutely. Given the following diagram, we know that AB is parallel to DE. So I'm going to trace over those two. This right here is parallel to this right here. And C bisects both AE and BD. So this point right here is bisecting AE, and it's bisecting BD. So we've created two triangles here. We have this triangle right here, and we have this triangle down here.
I have a question. So, is it fine to be color code on the paper because at least for me it's easier.
Yeah, you can, if you have colored pens or colored pencils that you want to use, you may absolutely do that. If you don't, but you want to borrow some colored pencils or markers from me, you may absolutely do so.
Right.
If the colors help you see things better, please, by all means, use colors. All right. So let's see what we've got. We know that these two lines are parallel. When we see parallel, we draw a what? Draw a Z. Drawing that Z helps me find my alternate interior angles. So I'm going to trace over my parallel line, down a transversal, and over the parallel line again. So if I match orange to orange, that would be this corner here and this corner down here. I could have gone the other way with my Z shape. I could have gone this way, in which case I would have found this pair of alternate interior angles. Is there anything that I'm allowed to mark in this picture even though it doesn't have to do with parallel lines and it doesn't have to do with bisectors? Vertical angles right here at C on either side. We can mark our vertical angles. So I know that all three angles in the top triangle are congruent to all three angles in the bottom triangle. And I know about two pairs of sides. So could I use side angle side to show these two triangles congruent? Yes. Side, side, and the angle in between. Side, side, and the angle in between. So we could use side angle side. Could we use angle side angle? Angle, side, angle. Or I could even do angle, side, angle. So yes, I can do angle, side, angle. Do we know about all three pairs of sides so that I could use side, side, side? No, we do not have side, side, side. And then statement number 4 is the triangles are not congruent. Well, we have enough information to show that the triangles are congruent. We can show it two different ways. So which of these would have to be correct? B. Statements 1 and 2 are both true. Statements 3 and 4 are not true. So anything there that says 3 or 4 or does not contain both 1 and 2 would not be fully correct statements.
So, to be honest, for most of number 16, I kind of got lost in. I still kind of understand how we got to that point.
How we got to which point?
I don't know, just like, how do you...
So you have to use the parallel lines to draw your Z's. You can draw two Z's. That lets you find two pairs of alternate interior angles. That's the orange ones and the purple ones.
Okay.
We're always allowed to mark vertical angles, even if it doesn't say anything about it. Vertical angles are always congruent, so I can mark my vertical angles here at C.
Alright.
And then it tells me that C is bisecting AE. This segment here, that means these two smaller segments, AC and CE, are congruent. And it's also bisecting BD, this longer segment here.
Yeah.
So that means that BC and CD are congruent.
Okay. Now that kind of makes more sense.
All righty.
This is a lot.
It is a lot, yes. What else would you guys like to see? Which one? 20. Absolutely. Let's go do number 20. Number 20 is the very last problem on the very back page. The first two top boxes have given me my reason. The reason is given. So I'm going to take this information and put it into those two top boxes. Into the first one, I'm going to put that IM and KN are parallel. And into the second one, I'm going to put that IM and KN are congruent. I know that the congruent has to go in the second box and that the parallel has to go in the first box, because if you look at this first box, there's 2 arrows coming off of it. That means there's 2 things that I'll be able to find from this. I can't find 2 things just by being told that they're congruent. But when I see parallel, we draw what again? Draw a Z. That's going to let me find my alternate interior angles. So IM and KN are both congruent, so I'm going to mark them with congruences, and parallel, so I'm going to mark them with parallel symbols, those little arrows. If I'm going to use those to draw a Z, this is one way that that could look. I went over my parallel lines, I connected them with a transversal, and I went over the other parallel line. And then I match orange to orange since I used orange highlighter here. So this angle up here is congruent to this angle down here. This angle right here, that's angle MIL. Angle MIL is congruent to, what could we call this angle down here? Yep, KNL or LNK. Angle KNL. What do we call that special angle pair there? Alternate interior angles. So these 2 are congruent to each other by the alternate interior angles theorem. That is not the only Z that I could draw with these parallel lines. And again, I know I can make 2 statements off of it because there's 2 arrows leading off of this. So going over the same 2 parallel lines, I could have connected them using the other transversal, using the other diagonal line. And if I connect them that way, then these 2 angles are my congruent angles. That would be angle IML and angle what? What would we call this one over here? LKN. Angle LKN or NKL. And why can I say that those 2 angles are congruent to each other? Yes, alternate interior angles theorem again. Whenever you see parallel lines in a triangle proof, we're going to use alternate interior angles theorem to say that angles are congruent. All right, let's look at what we have marked up. I'm going to look at just one of the triangles because the other triangle is marked up in a corresponding way. What do we have marked on the triangles? Yep, I have an angle here. I have a side here. And I have an angle up here. The side is in between the 2 angles. The side touches my 2 angles. So I can say these 2 triangles are congruent by angle, side, angle. And now I need a triangle congruent statement. I can say that triangle, let's see, triangle IML is congruent to triangle. Now I have to match up the corresponding congruent parts. I corresponds to what on the other triangle? N. I and N correspond. So I have to start with N here. M corresponds to K. They're both marked with the 2 arc marks. So NKL. Is that what we were asked to prove?
No.
What were we asked to prove? That IL is congruent to LN. Segment IL is congruent to segment ln. Thank you, sir. Are those already marked as congruent? No, those are parts of two separate triangles. Why would I be allowed to say that parts of two separate triangles are congruent to each other? CPCTC. These are corresponding parts. These two pieces are corresponding parts of triangles that we just showed are congruent. And so they are congruent to each other. That congruent triangle part is what we just showed right up here. Corresponding parts of congruent triangles are congruent. CPCTC. What else would you guys like to see? 15? Absolutely. Number 17? Yep, we'll do 15 then 17. 15 is a really good one. There was one like this on the skills check yesterday. Or sorry, not like this one. There was one like this on the first skills check, not yesterday's skills check. First skills check that we did in this module. And we struggled with this one. First thing I notice is in this drawing, angle 3 here is outside of the triangle. We call it what when it's outside of the triangle? Not alternate, just exterior though. Alternate exterior is when I have a pair of angles that are both outside of the triangle. This is an exterior angle. And these two angles, angles 2 and 1, they're not touching angle 3. What would we call those? These are interior angles, but because they don't touch angle 3, we're going to call them remote interior angles. And we learned a theorem right at the beginning of this module. It's my exterior angle theorem. This says that my exterior angle is equal to the sum of the remote interior angles. So that means the measure of angle 3 is equal to the sum of my two remote interior angles, measure of angle 1 plus the measure of angle 2. Well, angle 3, we were told up here, is 2x plus 9. So that's going to go on a side all by itself here. 2x plus 9 equals angle 1 is x minus 10. And angle 2 is 3x minus 7. Bring down my plus sign. And now we can solve this. This was the most commonly missed problem on both the skills check that we took and when I gave this test last year. We're going to combine our like terms together. So I'm going to combine my x's. I have x and 3x. That would combine together to give me 4x. And then we're going to combine our constants. I have a minus 10 and a minus 7. That combines to give me minus 17. So I have 2x plus 9 equals 4x minus 17. Get the x's to the same side next. So I'm going to subtract 2x from both sides. I get 9 is equal to 2x minus 17. We're going to add 17 to both sides to make it cancel out over there on the right. What is 9 plus 17? 26. So 26 equals 2x. Divide both sides by 2. What is 26 divided by 2? 13. So 13 equals x. That's one of the things we were asked to find. What else were we asked to find? Measurement of angle 2. Well, we said the measurement of angle 2 is 3x minus 7, according to what they told us. So that would be 3 times 13 minus 7. What is 3 times 13? 39, and 39 minus 7? 32. So angle 2 is 32 degrees. Again, this was the most commonly missed question on the test last year, and it was the most commonly missed question on the first skills check of this module. The exterior angle is equal to the sum of the two remote interior angles. So the two inside angles that don't touch my outside angle add together to equal my outside angle. All right, 17 was the next one that I was asked for. Given triangle AWE is congruent to triangle SOM, this is what I'm using right here. Fill in the table below and answer the question. Corresponding angles. Well, I know that angle AWE is congruent to angle SOM. Same order that it's in right here. There's another angle pair that is congruent. WEA. So I did middle last and then wrapped around to the beginning. Is congruent to, what would match that same pattern on the other one? OMS. So angle OMS. And then we need our last angle pair. So I'm going to go the other way. WA, and then wrap around to the back. WAE, angle WAE is congruent to, what would follow that same pattern on the other one? OSM. Angle OSM. And then we're going to match up our corresponding sides. So I'm going to look first two letters. AW, SO. Segment AW is congruent to segment SO. What would be another pair of corresponding congruent sides? WE and OM, middle and last letter, middle and last letter. WE congruent to OM. All right. And then we have one last pair of corresponding congruent sides. What would my last pair of sides be? AE and SM. AE is congruent to SM. And then it says, what is the reason that these parts are congruent? What type of parts are they? What did I keep calling them? Starts with a C. Corresponding parts. So why are these congruent? Yes, corresponding parts of congruent triangles are congruent. CP, CTC. All right. That is, unfortunately, all that we have time for today. I have posted the answer key for anything that you still want to see that we didn't go over. So if you look at our Canvas page for today, where it says Review for Module 5 Test Day 2, scrolling all the way down to the bottom, right here is where the videos will be posted. So you might want to check out the videos from another class period because they asked about different questions. all the way down at the very, very, very bottom, Module 5 Test Review Answer Key. If you click on that, you will find my answer key with all of my work on it here.